So Ruhib's talking about celestial navigation and distances. Let's check the directions. This is from North Florida to, I think, Sudan, near the equator in Africa. So it looks like we have to travel north. That's weird. So I'm around 30 degrees north, and to get by the equator, I have to travel north to go south. That's weird. Let's check it a little bit closer to the equator. So still have to travel north, maybe even a little further north. That too, that strikes me as a little weird that I have to go north to get south on their globe. I mean, that probably works on the AE map, but so let's check it south around 25 degrees. Well, that's weird. We don't have to go south in the southern hemisphere like we had to go north in the northern hemisphere. So let's go closer to the equator and check it out. Nope, still not going south in the southern hemisphere, but having to go north in the northern hemisphere. So that's just weird. Let's check these distances. So they say that 69 miles per degree doesn't work on a flat plane. So let's just test it. So 69.1 miles, and we'll put in for 1 degree change. So we'll put in 89 degrees in the triangle calculator for a flat plane, and what do you know? We get 3958.7, the exact globe radius. So if you're wondering where they got that from, where they even got their radius from, there you have it, right there, doing flat plane trigonometry. And they just moved it to the center of their Earth. But let's see how that works on a flat plane. So let's check it. So let's check 138.2 miles and see if we get the 2 degrees. Let's check it, because that's weird. They look like they hijacked the radius to me. But so I put in 3958 for our height to Polaris, because that's what we get when we triangulate on a flat plane. And for distance, I put 138.2 degrees. Let's see what that comes out to in the triangle calculator. What do you know? 88 degrees on the dot. That too is weird. So 138 miles we traveled, and it's 69 miles per degree is working just fine. So let's do 207.5. That's should come out to 3 degrees or 87. There it is, 87.006. But still, immeasurable basically. So let's check, let's move up a little further. Let's go and let's do 691. That should give us 10 degrees or 80 degrees. And surely it does. 80.0 degrees. So seems to work pretty good on a flat Earth, because we've traveled 690 miles and it's still working just fine. So let's do 15 degrees. That's 1,036.5 miles. And we put in 1,036.5 miles. Let's see if what we get in 75 degrees. What do you know? Coincidence? So let's try 20 degrees. Let's try 69.1 times 20. That's 1,382. So we're going to put that in the triangle calculator. We put in 1,382 and calculate, and 20 degrees. Must be a coincidence. So it's not until you go 1,500 miles before you're off by 1 full degree. And that's a long way. It's a little under 1,500 miles. So 20 degrees is 1,380.2 miles on a plane. So let's see what that comes out to. So if we're driving 70 miles per hour, so let's say a 20 degree angle to a star, or, well, 70 degrees. That would 70 miles per hour. That's 2 10-hour days of driving non-stop. That's a long way. Let's see how long it would take to check that in a boat. Going 10 miles per hour, we'd have to travel for almost 6 days. So these distances that work so perfect on a globe they're uncheckable. They're untestable. Them are some long distances. But so I want to talk about the eclipse. This was the moon when it was about just a little crescent, almost fully eclipsed, but not quite. You see the sky's dark, and here's the sky's. This is the moon. This is looking west, and it's still dark. It looks a little bit brighter. The sun's starting to come up a little bit. It's probably not quite above the horizon though, and the facing west is still dark. But I show a sequence because I finally wait and until the last minute before the moon disappeared, and I film it and I catch the sun poking its head up above the clouds. But by that time, the moon side of the sky was daylit also. So check out the video. This is leading up to the video. This is the Selenelium eclipse recorded from Jacksonville, Florida on November 8, 2022. The sun and moon are both above the horizon, and it is said to be the Earth's shadow casted onto the moon. I'm not so sure. You be the judge. The sun is about 2 degrees above the horizon. The moon is probably about 15 degrees above the horizon. And I'm about 30, probably 30 feet above sea level. So you tell me. And for any naysayers, I do realize you can't see the sun very good because it's so washed out. But you've seen how high the moon was above the horizon. So had it not faded out, I could have easily got it 5 degrees lower, which puts the sun 5 degrees higher. But I probably could have got it more like about 10 degrees lower. But still, I don't see how this works on a ball. Now, last but not least, I wanted to talk about refraction and the globe model refraction. This is a tank full of sugar water. Their only demonstration, and their demonstration proves a flat Earth. Look, we have direct line of sight. See that black line at the bottom of the city? That represents line of sight. And look at the lower you go, the more the bottom of the city skyline appears to vanish. It's bottom up obstruction with direct line of sight. So their their demonstrations literally backfire on them. So their only demonstration of refraction on a globe literally helps prove the flat Earth. So I want to welcome Ruhif to the flat Earth. There you have it right there. This is what refraction does. Y'all say y'all proved it. The light bends down toward the denser medium, and well, okay. Well, there's what you get. You get half of the city missing with the light refracting downward. So welcome to Flat Earth, Ruhif. There's your evidence from Mick West. Um, you say you prove that the light does what it does, and well, there's the result. Bottom up obstruction. So I don't know what else to say. Let's get on with it.